Hello, my name is Jared Skeens, and welcome to the Zoom room. Today we want to look at Pure Maths 1 from the new 2020 syllabus. So this is the first of the past papers, May-June series 2020 for Pure Mathematics 1 in the Cambridge International AS level. So if you notice, it's now up to an hour and 50 minutes long. Before it was an hour 45. So now it's an hour and 50 minutes long, which probably means you can expect maybe one more question on the test. It is still worth 75 points. And so there was a little bit of new material added to the syllabus this year, and also a little bit taken away as well. So let's get into the test. Here's question number 1. The sum of the first 9 terms of an arithmetic progression is 117. The sum of the next 4 terms is 91. Find the first term and the common difference of the progression. So since we have 2 variables, it's probably going to be simultaneous equations. So here's the sum of the first 19, or sorry, the sum of the first 9 terms is 117. The sum of the next 4, so if we take the 9 plus the next 4, that would give us 117 plus 91. So here is your formula. It's in your formula sheet that Cambridge provides. And this is your formula for summation of terms for the arithmetic progression. And so we have 117 equals n over 2, n being 9, parentheses, 2 times the first term, which we don't know yet, plus n minus 1 times the difference. And so as we simplify that out, I multiplied the 2 to the other side, got 234 equals 9 times 2a plus 8d, and then divided the 9 to the other side, and got 26 equals 2a plus 8d. If we work the other side, the other equation, 117 plus 91 adds up to 208. This now, 9 plus 4 is now the 13th term, or sum of the first 13 terms. So 13 divided by 2 times 2a plus n minus 1 times d, where n is 13. Multiply the 2 to the other side, 416 equals 13 times 2a plus 12d, and divided the 13 to the other side, 32 equals 2a plus 12d. Bring over our equation from the other side and subtract to eliminate the a's, and you solve through and you end up with a difference of 3/2 or 1.5. Plug that into either one of your previous equations, work that out for a, you get a equals 7. So that was pretty straightforward there. Question number 2, coefficient of 1 over x and the expansion of parentheses kx plus 1 over x raised to the 5th power plus parentheses 1 minus 2 over x all raised to the 8th power is 74. Find the value of the positive constant k. Well, the coefficient, or the term whose coefficient we're looking for, 1 over x, is the same thing as x to the negative 1. What I like to do, there is an algebraic way of doing this. However, I use the mental approach. Take my different combinations of 5, 5, 0, 4, 1, 3, 2, 2, 3, 1, 4, 0, 5. Look at the x's in your a and b term, and look at which exponents gives you the combined outcome of a x to the negative 1, or 1 over x. So see here with the 2 and 3, you would have 2 x's in the numerator, 3 x's in the denominator, and that gives you a total of 1 x in the denominator. Over here with the 8, again, 8, 0, 7, 1, 6, 2, 5, 3, 4, 4. I didn't even finish it because with the 1 here, this whole left-hand column of numbers or exponents to the 1 will still only give you a 1. The x is over here. We need to have 1x in the denominator. So 7, 1 will give you that 1x in the denominator. So that was pretty easy to spot. Now it's just a matter of running your formula, which again, your formula is in your formula sheet. So you can check that out. 5C3, so that means we have a fifth power, that's our N, so using our NCR key, the N is the 5, the 3 comes from the second column. When you're doing your NCR key, the R comes from the second column of this listing, so 5C3. The first column would be your exponent for the first term, so the first term is kx, so that's kx to the second power. And then your second column is also the exponent for that b term, the second term. So positive 1 over x cubed plus, then we have this one over here. So 8 is the n, 1 is the r, so 8c1 with our first term being 1 raised to the 7th power times the second term is a negative 2 over x. Don't forget the sign. So you have a negative 2 over x raised to the first power, and both of these combine to give us 74. Now remember, the 74 is the coefficient only, so we don't have to worry about the variable later on. So when we multiply this out, 5c3 is 10, then you get a k squared x squared, and then you have an x cubed in the denominator. Over here, 8c1 is 8, 1 to the 7th power is 1, and then 1 power of a negative 2 over x. Here's the negative out front, the 2 over x. When you simplify this, these x's cancel, giving you 10k squared over x minus a 16 over x equals 74. Remember, we're only dealing with the coefficients. So now that we've established these as actually being 1 over x, we can get rid of the variable and just work with the coefficients. So 10k squared minus 16 equals 74. 10k squared equals 90. K squared equals 9. K equals 3. Remember, it asks for the positive value of k, so we don't need the negative 3 on this. Moving on to number 3. Each year, the selling price of a diamond necklace increases by 5% of the price the year before. The selling price of the necklace in the year 2000 was $36,000. So for part A, write down an expression for the selling price of the necklace in years later, and hence find the selling price in 2008. Actually, this part of the question goes back to IGCSE material. So remember, when you increase by 5%, you add that to 1 being the original 100 that you are then increasing by 5%. Make sure you change that to a decimal, or you could use fraction if you happen to be the person who likes to use fractions there, that's fine as well. So our sum for, or our sales, this represents our selling price for the nth year, will equal 36,000, that's our original price, times 1.05, so that's the original plus the rate, the yearly rate, and then raised to n being however many years that you want to calculate it for. So plugging in an 8, because we're going from 2000 to 2008, plugging in an 8 for n, calculating it up gives $53,188.40, or to 3 significant figures, it's just 53,200. Now part B actually gets into the AS level material. A company that makes the necklace only sells one each year. Find the total amount of money obtained in the 10-year period starting in the year 2000. So we want the sum over 10 years, starting with our first term being the 36,000. And then again, this formula, the sum formula, now this is a geometric progression because you have that rate that you have in there. So this is a sum for geometric progression. The formula's in your formula sheet, just look it up. So you get 1 minus your rate, which is 1.05, raised to the n power, which is 10, divided by 1 minus the rate, 1 minus 1.05. So you simplify that out on your calculator, and you end up with a sum over 10 years of $452,804.13. If you change it to 3 significant figures, you get $453,000. Number 4, the diagram shows the graph of y equals f of x. So we have that here in the diagram, where f of x equals 3/2 cosine 2x plus 1/2 over the interval from 0 to pi. State the range of f. Well, remember this 1/2 in front, or sorry, in the back. When I write it, I usually write it in the front, but they've put it in the back. This 1/2 is your center line, and the 3/2 is your amplitude. The amplitude tells you how far above and below your center line that your graph goes. So we start with our center line 1/2, add the amplitude 3/2, we get 4/2 or 2, and then you take the center line minus the amplitude, which gives you a -2/2, which is -1. So the range of our function, our f of x, is going to be between and including -1, 2, and including 2. Part B, the function g is such that g of x equals f of x plus k. So remember, this plus k is what's going to change your center line. And where k is a positive constant, the x-axis is tangent to the curve y equals g of x. So that means up here, we need to take this graph, we're going to add a constant to it, which basically just moves it up the y-axis. And we need to move it up such that the x-axis becomes tangent to the graph. So this here, if you remember, our range is from -1 to 2. And from 1/2 to 3/2, we have where we have that change there. So notice from -1, we had to move it up to 0. That means we added 1. So notice now this runs from 2 all the way, or this one here runs from 3 because we added 1 to it. You notice the bottom was at -1 and now it's at 0. So the whole thing's being shifted up 1. So that means our high point goes from 2 up to 3, down to 0, and back up to 3 again. So our k then is 1. In other words, this entire graph was raised by +1 on the y-axis. So that's the location of k in this formula. Hence, describe fully the transformation. Well, obviously this is a translation, meaning we've simply slid the graph somewhere else on the graph paper. It's not a reflection or anything like that. So it's a translation, and I used a column vector to describe the translation. The top number is the x translation value, the bottom number is the y. So notice it was not moved left or right, it was only moved up by 1. So I used a 0, 1 column vector. You could also state it in words like 0 on the x-axis, 1 on the y-axis, something like that. Part C, state the equation of the curve, which is the reflection of y equals f of x in the x-axis. Give your answer in the form of y equals a cosine 2x plus b, where a and b are constants. Well, remember, if you are reflecting over the x-axis, that means you started with a negative on your y variable. If you reflect over the y-axis, it means you're starting with a negative on your x variable. So since this is being reflected over the x-axis, our y variable, which in this case is the f of x, has a negative on it. And all we have to do is divide that negative to the other side, change our f of x into the y here. That negative distributes through, giving you a -3/2 for the a and a -1/2 for the b in the form that they have provided. So that's the reflected equation. Question number 5. The equation of a line is y equals mx plus c, where m and c are constants. And the equation of a curve is xy equals 16. Given that the line is a tangent to the curve, express m in terms of c. Well, this line as a tangent means two things. First of all, it means that it actually intersects, which means we can set the equations equal to each other. And the second thing it means is that it intersects only at one point. So first, let's deal with the intersection. It means we can set them equal to each other. And if we multiply this x to the other side, we notice that we start getting a quadratic, mx squared plus cx, and I just subtracted this 16 to the other side to get 0. So now that we have this quadratic, that should automatically take your mind to the unit, quadratics unit, where when you have one point of intersection, that should take you to your discriminant, the b squared minus 4ac, and for 1 point, then it equals 0. So b squared minus 4ac equals 0. Take out your a, b, c. The a is m, the b is c, the c term is negative 16. So here's b squared minus 4ac from this quadratic up here. And then you simply express m in terms of c, meaning you're making m the subject. So we subtract the c squared to the other side, divide by 64, and there we have m in terms of c. Moving on to part B, given instead that m equals a negative 4, find the set of values of c for which the line intersects the curve at 2 distinct points. So now we replace the m with negative 4. Now, I like my first term to be positive, so I distributed the negative through. You don't have to, but I like to. So I did that. Now for 2 intersecting points, that means your discriminant is greater than 0, which also matches the words up here, set of values. When you see that phrase, set of values, it means you're going to get an inequality for your answer. So 2 distinct points means our b squared minus 4ac is greater than 0. Plug in those from your a, b, c on your quadratic here and solve it for c. And you get down here to c squared greater than 256. Now remember, when you square root both sides of an inequality, exponents is a fast way of multiply and divide. And remember, when you divide by a negative, it flips the inequality. And when you square root a number, you get both a positive and a negative. So you should end up with 2 statements. The positive value of your root, your inequality will stay the same. So you have c greater than 16. The negative root of your 256 will flip the inequality, so you get c less than negative 16. So here are the set of values, actually sets of values, c greater than 16 and, or could say or, actually or would probably be better because they both can't be true at the same time. So c greater than 16 or c less than negative 16. Moving on to number 6, functions f and g are defined for the set of all real numbers such that f of x equals 1/2 x minus a, g of x equals 3x plus b, and where a and b are constants. Given that the g of 2 equals 10 and the inverse function of f of 2 equals 14, find the values of a and b. So here we have 2 variables, we have 2 equations given to us. So let's start with our g of 2. So we start from the inside and we work out. So first we put 2 into the first g. So g of 2 means we plug 2 in for x. So we get 3 times 2 plus b, which is 6 plus b. Now we take that answer and plug it into G again. So notice the 6 plus B is plugged in for our X in here. So our G of 6 plus B equals 3 times 6 plus B plus the B out here. Don't forget to add that B out here. When you simplify this, you get 18 plus 3B plus B, which is 18 plus 4B, which only has one variable in it, so we can actually go ahead and solve that. We get 18 plus 4B equals 10. The 10 comes up here from the composite function equation they provided. So we get 18 plus 4B equals 10, 4B equals -8, therefore B equals a -2. Now for the other one, find the inverse function of X first. So switch X and Y, make Y the subject, and now evaluate it for 2. So when you evaluate the inverse function for 2, remember again, switch X and Y, solve for Y or make Y the subject, plug in the 2, so we get 4 plus 2A, then according to the equation that they provided, set it equal to 14. So 2A equals 10, A equals 5, and we already got B equals -2. There are our answers for that. And I went ahead and plugged those in up here for the A and B. Using these values, find an expression for G of f of X in the form Cx plus D, where C and D are constants. So G of f of X means to take your f of X and plug it into the G of X. So here's our f of X, which we want to plug into the X of the G of X. So that gives us 3 times 1/2 X minus 5. And again, don't forget this -2 here at the end of the statement. We distribute the 3 through, combine like terms, and so our G of f of X equals 3/2 X minus 17, where the C value is the 3/2 and the D value is the -17. Moving on to number 7, now we get into trigonometry. Part A, prove the identity. So remember with these show or prove problems, we want to take the left side and make it equal to the right side. So we start with the left, 1 plus sine theta over cosine theta plus cosine theta over 1 plus sine theta. We are adding fractions, so when you add fractions, you want a common denominator. So this side needs the 1 plus sine theta multiplied top and bottom. This side needs the cosine theta multiplied top and bottom. So when you multiply 1 plus sine theta plus times 1 plus sine theta, you get 1 plus 2 sine theta plus sine squared theta, and then the cosine times cosine is cosine squared theta, all over now our common denominator of cosine theta times 1 plus sine theta. Remember the identity, sine squared theta plus cosine squared theta equals 1. Substitute that in, add it to the previous part, so you get 2 plus 2 sine theta. Then there's a 2 common to both, so you can factor it out, which then allows you to cancel top and bottom, leaving you with the answer that we want, the 2 over cosine theta. So now that we've done that, part B, hence, and that word hence means you want to look back at your previous work, solve the equation, and here it gives an equation now equaling 3 over sine theta. So this left-hand side here, this entire left-hand side we just proved is 2 over cosine theta. So we want to take that, that's what the hence is there for. We want to start with that and now set that equal to 3 over sine theta. So just cross multiply, divide by cosine. Whenever you get an equation with both sine and cosine in it, most likely you're going to turn it into a tangent. Tangent is sine over cosine, so we divide both sides by the cosine so that we can turn it into a tangent. Then we divide by the 2 to get 3/2. Remember, tangent is positive in the first and third quadrants. And since our domain statement is 0 to 2 pi, that means you're in radians. So don't forget to set your calculator setting to radians. With trigonometry, you always need to double check what your calculator setting needs to be in. So the domain statement will help you identify that. Since it uses pi, it's radians. So theta, when you do it on your calculator, the inverse tangent of 3 over 2, then theta will equal 0.983. And then to get the third quadrant, all you need to do is add it to pi. Remember that 180 degree in the negative x-axis direction in radians is pi. So we're going to go past that into the third quadrant. So we're going to take pi plus the 0.983. I probably should have wrote the plus pi down here so you could see where I got the 4.12 from, but it's 0.983 past the negative x-axis, which is pi. You add those together to get your 4.12. Don't forget, use your calculator value of pi. You're not allowed to use 3.14. You can use 3.142, but just as easy to use your calculator button for pi. Number 8, in the diagram, ABC is a semicircle. ABC is a semicircle with a diameter of AC, center at the origin, and radius of 6 centimeters. The length of arc AB is 15 centimeters, and the point X lies on AC, and BX is perpendicular to AX. Find the perimeter of the shaded region BXC. So in case my scanned copy is a little difficult to see, this section right in here is the shaded section, this BXC part, this little chunk at the end. That's the shaded part, and we want to find the perimeter. Well, let's start, since we have an arc length here, let's start, and we have the radius, let's find our degree measurement, or our angle measurement, I should say. Technically, with this problem, you probably could use degrees or radians. I don't see anything in here that would prohibit you from using degrees. I know some people prefer to use degrees. However, with these arc length and sector area type questions, the radians formulas are actually the more simple formulas. And in the AS level, when they work with this kind of a topic, they use only radians anyway. So I would recommend that you use radians, although for this particular example, I think you could get away with degrees, but make sure you remember the degree formula is different from the radian formula when it comes to arc length and sector area. So the radian formula is arc length equals r theta. So you have an arc length of 15, that's up here, and you have a radius of 6. So that means our angle is 2.5 radians. Then to get this in here, you got a straight line. So supplementary angles, your straight line in radians is pi. So pi minus 2.5 gives 0.6416. Then you can now solve for both the height, the opposite side, and the adjacent side of this right triangle. So sine of 0.6416 is opposite over hypotenuse. Solve for the height. The height happens to be bx, and you get 3.59. Then solve for the adjacent side. Cosine of 0.6416 is adjacent over hypotenuse. Solve for that, and that corresponds to the OX part. So that's OX, I just put it as X here. And that comes out to 4.8068. Now remember, we don't want OX, we want X to C. So the whole radius is 6, minus the X will give us that little section in there. So we want 6 minus that value gives us 1.193. That is the XC part. Now we need to find the arc length, and since we've already found the angle and we have the radius, we can calculate the arc length pretty easily. Radius times theta, the angle measurement, and we get 3.8496, which is arc BC. So perimeter is just adding those three sections together, BX, XC, and CB. And we have our numbers, 3.59, 1.193, and 3.8496. And they add up to 8.6326, or 8.63 to 3 significant figures. Moving on, here we have our next question. Here. This is, I guess, the question number. This question up here was question 8. So this would be question 9. The 9 didn't get picked up in my scan. So this is question number 9. The equation of a curve is y equals 3 minus 2x cubed plus 24x. Find expressions for dy dx and d squared y over dx squared. In other words, just find the first and second derivative. This should be straightforward using your derivative formula, which, by the way, is also in your formula sheet. So make sure you are very familiar with your formula sheet. There is a difference between the formula for a basic term and for an expanded term. So this one over here with the parentheses is expanded. You multiply the exponent to the front, then you subtract 1 from the exponent, then don't forget to do the derivative of the inside, and you multiply by that -2. Then the derivative of 24x is just 24, because that's a 1 times 24 is 24. The 1 minus 1 is 0. Anything to the 0 power is 1, and 1 times 24 is still 24. Then we just simplify this. -2 times 3 is -6. So I just smooth that up there a little bit. That's our first derivative. Now for the second derivative, we just continue on a second time. So 2 times the -6 is -12. Subtract 1 from the exponent gives us 1. Again, this is expanded form, so don't forget the derivative of the inside. Be careful, it's not always the first number, so don't multiply it by 3. The derivative of 3 cancels out. The derivative of -2x is the -2. So you should be multiplying by -2, not the 3. And then the 24 disappears because derivative of a constant is 0. Simplify this. -2 times -12 is a positive 24 times 3x minus, or 3 minus 2x. You could leave it like that. I went ahead and simplified it further by distributing and made it 72 minus 48x. But either one of these last two lines would be fine for that as the second derivative. Moving on to part B, find the coordinates of each of the stationary points of the curve. Well, stationary points is your first derivative equals 0, set equal to 0. Why 0? Because stationary point is where your slope line is horizontal. It's at the bottom of a curve. That's your minimum or maximum. Okay, so that means your slope is horizontal, which means your slope is 0. So you set your first derivative, which represents slope, equal to 0, and we solve for where that occurs at. So subtract 24, divide by the -6, square root both sides. Don't forget the plus or minus sign when you square root both sides. So you need to calculate both out separately. 3 minus 2x equals 2, therefore x equals 1/2, and 3 minus 2x equals the -2, so x equals 5/2. Those are the two x coordinates. It says find the coordinates, not just the x coordinate. So that's the x coordinates. So we need to plug those into the original function. Remember, when you're finding ordered pair or coordinates, you always plug into the original function. The original function is this one back here, the y equals this up here. So we start with that, and we plug in right here our 1/2, work it out, we get a y value of 20, and then plug in the 5/2 for your x value. You work that out and you should get a 52. So here you just have to pay attention to your orders of operations and calculate correctly on your calculator. So here are our two sets of coordinates, 1/2 20 and 5/2 52. Part C, determine the nature of each stationary point. Well, this is where we're going to use the second derivative. So we take our second derivative that we have up here, the 72 minus 48x, and we plug into it our x coordinate only, the 1/2. And so for this first one, when we plug in 1/2 into the second derivative, we get 48, which we need to interpret that as being positive. In other words, greater than 0. And so I use a little positive means you're smiling. And so that would be a minimum because you're at the bottom part of the smile. And so the 1/2 20 coordinate is a minimum. Then you plug in the 5/2, work it out, you get a negative 48, which you interpret then as being negative because it's less than 0. And people who are negative are usually frowning. Therefore, it is a maximum because it's at the top of the frown. So your 5/2 52 is the maximum. So when it says determine nature, it means identify your stationary points as a minimum or as a maximum. Number 10, the coordinates of points A and B are -1, -2, and 7, 4, respectively. Part A, find the equation of the circle C for which AB is a diameter. Now this is part of the new material of the 2020 syllabus that deals with circles. And so the A and B are the diameter. So the two things that you need for the equation of a circle are the radius and the center. Well, the center is the midpoint of the diameter. So just find the midpoint of our diameter, the A and B being the ends of the diameter. So the midpoint would be adding your two x values together, divide by 2, add the two y values together, divide by 2. So we get a center of 3, 1. Now to find the radius, all we need to do is go from the center to either one of the endpoints. And I chose the point B. So the distance between the center and the outside of the diameter, or C to B, and I used the distance formula, plugging it in. So the difference, the square of the difference between your x values plus the square of the difference between your y values. And you see that this comes out to a very nice square root of 25, which gives us a radius of 5. So now your formula of an equation is x minus, don't forget to change the sign of both of your center components because these numbers are being attached to the variable. So when they are attached to the variable, you have to change the sign. So x minus 3 quantity squared plus y minus 1 quantity squared equals r squared. So you could either put 5 squared or just go ahead and multiply it out and put 25. This is your equation of this particular circle. Part B, find the equation of the tangent to the circle at point B. Now, point B is the point 74, and B was on the diameter. So if your tangent, is, this external line is tangent to your diameter, it means it's perpendicular